So how does it work? So there's the distance and time. So to describe this, we can say journey A is decelerating away from home because the distance from home is increasing, right? The distance is getting further away from home, the distance is increasing, but at a decreasing rate because it's getting slower. Hopefully you can see how it works. The decreasing rate because it's faster at the beginning, but then gets slower. So that's slow. If it's not as steep, that's fast. So we say it's a decreasing rate. Does that make sense? Okay, let's continue. Let's look at journey B. Journey B accelerating away again from home because the distance from home is increasing. Right, it's going upward. So both are going upward, they are increasing. But in this case, it starts off with slow and then gets up faster, right? So we say at an increasing rate. Let me write clearly. Increasing rate. Yep, got it. All right, let's move on to the next one. You just have to fill out 2 words and draw some tangents. Okay, let's move on to the next one. Accelerating towards home. So because it's going downwards, so we say it is decreasing. It's going down. But if you look at the gradient, it's actually getting faster, right? So slow first and then fast. So we say at an increasing rate. Does that make sense? Now you know how to describe change using graphs to describe change. So now we can describe the next graph. Like before, it's decelerating towards home. So if it's increasing rate, I've got to highlight this. Accelerating if it's increasing rate, and if it's getting slower, we say it's decelerating. Okay. So in this case, it's decelerating, it's getting slower. So we say the decelerating towards home because the distance from home is decreasing at a decreasing rate because it's getting slower. So it's fast before and then slow, slow. Fast. Yeah. So it's decreasing rate, it's getting slower. So we say it's decelerating. Alright, decelerate. Opposite of accelerate. Okay, so of course in the exercise you'll be asked to describe this using this language, either increasing or decreasing, at a rate of increasing or at a decreasing rate. Okay, so you need to describe this. Now we'll go to the next page. What have we got here? Example on this distance time graph. What to do? Speed. Must be here. Is that for the next few pages? Yeah, I think so. Yeah, that's good. We're going to use these words for the next example. Yep. Okay. This distance time graph shows various journeys, each with distance measured from home. That is, distance is 0. For each graph, select and copy the correct description of how the distance from home and the gradient and the speed are varying. Okay, so we're going to select these words and fill it in this blank space. All right, let's look at, so we have to talk about the graph in 3 aspects: the distance from the home, gradient of the graph, and the speed. Let's look at the first one. Distance from home, we will say it's increasing, right? It's going up. So we say increasing distance from home. So we use the first one because it's going up. Gradient of the graph, now the gradient could be positive, positive varying, positive constant. In this case, we're going to choose this one. It's positive because it's going up, but it's constant. How do I know it's constant? Because the gradient doesn't change, it's a straight line. So when it's a straight line, it's a constant gradient. Okay, so positive constant gradient. Let me write it again so I can write it a bit clearer. Constant, like that. Okay, let's look at the next one. Do we have to talk about speed? Oh yeah, there's the speed, yeah. in this case, the speed is stationary speed, lower constant speed. Yeah, that will be a lower constant speed. So the speed doesn't change, it's a constant speed. So we say it's lower constant speed. Because the speed doesn't change, it's the same speed. But it's slow because the gradient is small. Okay, that's why lower constant speed. Okay, next one, we say distance from home is decreasing this time. Decreasing. And the gradient of the graph is negative, but constant gradient. Okay, so you write negative, constant. So if it's a constant gradient, the speed will be constant too. So the speed and the gradient are related. And then let's look at the speed will be lower constant, high. Yeah, in this case will be high constant speed. So the speed, you see, is steeper. It's steep. If it's steep, we say it's higher speed. Higher constant speed. Hopefully it makes sense. All right. All good. So we got that done. We're going to do more. Yep, it's recording good. Okay, hopefully you're ready for the next 2 pages. Our next page, we have lots of graphs to describe. Okay, let's move on. So remember the wording, so we may refer back to it later on. Next one. Okay, distance from home, this one will be increasing. What I'm going to do is just write all of them. So that's increasing as well because they're all going up. And we'll say this is decreasing, so we can compare and contrast. Decreasing. All right. So now you know how to describe distance as increasing or decreasing by looking at the direction of the graph. Yep. Okay, let's continue. Let's look at the gradient. Let's look at what are the choices for the gradient. Gradient could be positive, negative. Okay, all right. So let's look at these 4. So I could already say this is going upward. So we say it is positive. So whenever it's increasing, it has positive gradient, right? Whenever it's going down, we have negative gradient. Negative. Okay, now we can contrast and compare all the 4 graphs. And in all of these cases, they're all varying gradients. So we say varying gradient. Because the gradient changes, as you can see, it's slow at the beginning, small gradient, and then the gradient increases, higher gradient. Does that make sense? So it's varying. The gradient keeps changing. So in that case, your answer for all of these are all varying. Okay, so now it's pretty cool. So all done. All right, continuing on. We still have to talk about the speed. So let's look at the speed. So in that case, this one, the speed is going up, isn't it? So we say it's increasing speed. Increasing speed. And what description do we say? If it's increasing speed, we say it's accelerating. And then this is decreasing speed because it's getting slower. We say it's decelerating. Decelerating. Right? This one, let me see, it's getting fast first and then slow. Fast and then slow. So we say it's decelerating. So we say decelerating. Oh, not decreasing, decelerating. 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 Decreasing speed. Decreasing speed. And this one's getting faster and faster, right? So we say it's increasing speed, which means that it is accelerating. Cool. I did them all. Okay, excellent. All right, after we do this, what else are there? We need to do 2 more pages, 5 pages today. Okay. All right. Hopefully you're ready. We've got 2 more pages to go. Then we have to look at graph of direct variation. So how does it work? So if you see a straight line graph that look like this, we say as x increases, y also increases. Examples of direct variation include number of kilograms of oranges you purchase and the cost of purchase. So the more orange you purchase, the higher the cost, right? So you can say this is the number of orange and the cost, right? And it's a straight line graph, and the graph is a straight line, I think, is a straight line. And the equation of that straight line through the origin is y equal to, we're going to use kx, where k is a constant. K is called the proportion, constant of proportionality. Constant, is that what they call in the textbook? I think. Did they describe it? Constant of proportionality, yeah. Constant of proportionality. Yeah. And you can say k is also the gradient. Okay. So we write, so whenever they are proportion, we say y is proportional to, the symbol for proportion is that symbol there, which means that y equal to kx. Okay, so the symbol for proportion is that alpha symbol. So we say y varies directly as x or y, as x or y, as x or y, or y is directly proportional to x. So we can say both ways. I think there's an or already. Okay. Y is directly proportional to x, or we can say y, x is varies directly as y. Oh, no, sorry. I said it wrong. Oops, sorry about that. Okay. I thought you can say the other way around. Okay. So y varies directly as x, or the other way to say that is y is directly proportional to x. Okay, like that. So you can either say directly proportional or varies directly whenever the two relationship is a straight line pass through the origin. Okay, so we did that, and then we're going to do some example. So that's example 2 we're going to do. It's very simple. So we say the word m is directly proportional to p. So when you see that statement, you can say m is proportional to p, which means that I could write the equation m equal to kp, where k is a constant. So to find the k, we use the values that's given. M is 90 when p is 20. And then you can find out what k is. Now k is simply 90 over 20, which is 9 over 2. So therefore your equation becomes 9 over 2p. Right? And then we use that formula to answer the next 2 questions. So find m when p is 16. So you go m equal to 9 over 2 times 16. That will be 8 times 9, 72. Right? Once you got the formula, you can work out the value of m. Or alternatively, you can work out, given m, you can work out p. So therefore, 20 equal to 9p, p equal to 20 over 9. Okay, good. So that's done. Any question? I've got one more page to go through. Okay, we have direct variation. We also have what we call inverse variation. So how does inverse variation work? The inverse variation reminds you of what graph? Reminds you of the hyperbola. That's what hyperbola graph look like. And remember the graph of equation of hyperbola, 1 over x, right? So you will see that as x increases, y decreases, right? That's inverse. So they do opposite to each other. Examples of inverse variation include the time it takes to construct a building, okay, and the number of workers hired. So the more workers hired, the less time it takes, or the more, or the less worker you hire, the more time it takes, right? It's inverse proportion. So the graph is a hyperbola, and the equation will be y equal to k over x, which is the equation of the parabola. So we write y is inversely proportional to 1 over x, so which means that y equal to k over x, okay? And then we say y varies inversely as x. Y varies inversely as x, or you can say y is inversely proportional to x. Okay, note the wording. So the word is varies inversely or inversely proportional. Okay. All right. So we're going to do an example. So the keyword is inversely proportional to inversely proportional. So you can write y is inversely proportional to x, which means that y equals to k over x. So we'll have to find out what k is. Now to find out what k is, we substitute y is 6, x is 10. So you do 6 equal to k over 10. Therefore k equal to 60. And then we update our formula. Therefore the equation is 60 over x. Or another way you can write it is xy is 60. The product is always 60. I think that both are okay. So let's say we're going to do the first one. Y equals to 60 over x, and replace x by 15. So it goes 60 over 15. So that means y equal to 4. Or when y is 12, you can work out what x is, right? So you multiply both sides by x. 12x equals to 60, which means x is 60 on 12, which is 5. All done. So it's pretty easy once you get the equation, and now you know how to describe change using all the terminology, and you can start exercise 9N today. Okay, you can start now. Thank you.